So I'm going to need my object still. My phone will still be my object. So with my cartoon, I can remove it now. So, come closer. I'm also going to remove my lens. So, now I'm going to fix the distance S. Remember, in displacement method, we fix the distance. That one does not change. The distance from the screen to the object is constant, does not change. So what do we expect? We expect two images. So I'm going to form the first image that is very small, but very clear. Okay. So that's the first image. I hope you can see it. Small but very clear. And it is forming around 6.5 centimeters. Okay, forming around, I'm at 6.5 centimeters. If I move forward, I lose it. If I move beyond that, I lose it. So it is playing around 6.5 centimeters. So that's my first image. Okay. Have you been able to take it? I focused, eh? So now the second image now should be bigger than by my object. So magnified image. Okay. And where is that image? I must move until I'm able to get it. Right now I'm at 20. Move forward. I'm at 17. I think that's where I'm getting the best. 17 centimeters. Okay. Move forward. Now that is small one. Move backwards. Around 17 to 20 there. You have to try and focus. Remember, there is a margin of error in every experiment. So I'm at 17 exactly right now. And you can see on the screen, the image is much better. Okay, so we're going to take that as our second point. So the first point is 6.5, where we get the smallest image, a diminished image. And the other one is at 17. Okay, so we are going to calculate S. We're going to calculate the focal point. The focal length, sorry. Now to calculate the focal length, the formula we said, I taught this in theory, that the focal length, F, remember focal length is small f. I have to rub this. F is S squared minus D squared over 4S. Okay. Now remember, S, I told you, is 25, the distance from the screen to the to my object, the phone. Then D will be equal to what? So I said we were at 17 minus 6.5. Okay, 17 minus 6.5, that is our D. So that gives us what? Let me calculate. So I want to calculate. So we have 17 minus 6.5, that is 10.5. So remember, everything is in centimeter. Now applying that formula, F then, focal length, will be S squared, that is 25 squared, minus 10.5 squared, divided by 4 times 25. So what does that give us? Let's calculate together. 25 squared, that is 625, minus, let's see, 10.5 times another 10.5, that is 110.25, divided by 25 times 4, that is 100. Okay, so 625 subtract 110.25, that is 514.75, divided by 100. So we get the focal length to be divided by 100, take 2 decimal points, 5.1475. So we can set that approximately as 5.12 centimeters by using the displacement method. So remember, the focal length of our lens is 5 centimeters. So considering that there's a margin of error in every experiment, so whatever we have gotten as 5.12 falls within the margin of error. Okay, so we have used the method of displacement to determine the focal length of our converging lens. Number 2, by putting the object between the principal focus and the center of curvature, we have been able to make a simple projector. I thank you for being with me up to the end. I hope you enjoyed the lesson. I'm asking you to kindly share with people you think will require this knowledge, and don't forget to watch my videos. So until the next time, thank you very much and goodbye.